Hey there, my name's Sam and I'm a math tutor on Wyzant, among other subjects. All right, let's read through this problem. What size square must be cut if the volume of the box is to be 40 cubic inches? All right, I'm already a little lost, but luckily there's more to the problem, so let's read through this. A box with an open top is formed by cutting squares out of the corners of a rectangular piece of cardboard and then folding up the sides. If x represents the length of the side of the square cut from each corner, and the original piece of cardboard is 10 by 7 inches, what size square must have been cut if the volume of the box is to be 40 cubic inches? Okay, I'd really encourage you to draw a picture on this one. And my picture might look something like this. So my original cardboard rectangle has an area of 10 by 7 inches or side lengths of 10 inches and 7 inches. Then they give us the nice rule that each corner has to be a square, which means that the height here and the length here, or the length here and the length here, both have to be x. And that's true of all the squares around the corners. So then I realized that each side length is also going to be 10 minus 2x. And at first you might be like, well, I thought this was x, not 2x. Remember, each side actually has two corners attributed to it. So it's 10 minus 2x inches for the blue and 7 minus 2x inches for the orange. All right. Unfortunately, though, I'm only kind of seeing two quantities, this 10 minus 2x and the 7 minus 2x. But volume, as we know, is supposed to represent the three-dimensional space that an object takes up, and the unit would need to be inches cubed. So I'm kind of confused because I only have two so far, but then I need to do a little bit of reasoning in my head to think, oh yeah, there's also going to be a height of this cardboard box, and the height is also this x, because kind of the corners will come together. It's a little hard to see, but I wish I could do like an animation on here, but of course I can't. So we also know that the length times the width times the height is given to be 40 inches cubed. And we can replace all of the length, width, and height with the actual values given to us in our particular visualization of the problem. 10 minus 2x times 7 minus 2x and x are all multiplied together to give us our three dimensions, 40 inches cubed. This one's pretty difficult to reason through. You could do something like maybe foiling these, which would take kind of a long time, or you could maybe put them in a graphing utility like I did to save a little bit of time. I think the key to this problem was actually the visualization piece and then plugging it into our formula and not the foiling piece. So what I did was I set the red graph to the expression on the left, and then the blue graph to y equals 40, which gives me the horizontal line. So it turns out there's actually multiple solutions, but only some of them are going to work. Because of course we can't have things like negative lengths. It wouldn't really make much physical sense. So we're kind of limited by the shorter side, which means x could be at most 3.5 inches. Great. So what I found is that if x is 1 inch, or x is 1.734 inches, then we get this desired solution. And of course, you can plug this into your calculator to confirm this is true, or you can maybe try to plug it in your head, although I don't quite know how you plug in the second one in your head because it's a lot of decimals to work with. Okay, hope it was helpful. Thank you so much.